Hello and welcome back to Higher Maths, Logs and Exponentials, Lesson 8, Interpreting Experimental Data. Two sets of data are often linked by exponential growth or decay. Logarithms can be applied to determine the equation of the function, so we can find a link between the two variables. So when would we use a logarithmic scale? So we would use the decibel measures logarithmic, earthquakes, the Richter scales logarithmic, looking at the brightness of stars in chemistry, the pH balance that we use to test for acidity and alkalinity, if that's a word. Is alkalinity a word? I think it is. Okay, so they all use logarithmic scales. So if there are exponential changes in the magnitude of the link between the two sets of data, we would use logarithmic scales to see if there is a link between the data. Okay, so two functions, or these functions can be of two separate forms, so y equals kx to the n, for example 5x squared, or y equals ab to the x, so for example 5 multiplied by 2 to the x. Okay. So number 1 here, results from an experiment are shown in the graph, so it's clearly a link between the two variables here. But we've not got y and x, so it's not just going to be y equals mx plus c, which would be a nice link, but it's log y and log x. So initially we would have had a look at plotting x against y and noticed that the link wasn't too obvious, so it was too complicated to work out. So we would take the log of both sets of data, so we'd take the log of y and the log of x. We've chosen to take log to the base 10 of y and log to the base 10 of x here. Part A, show this graph represents a relationship of the form y equals kx to the n. Part B, determine the values of k and n. So what I need to do here is show that using my log rules, or our log rules, or the log rules I should say, they're not ours, they're everybody's. Start off with y equals kx to the n and get it into the form of log to the base 10 of y equals m log to the base 10 of x plus c. Because it's not just going to be y equals mx plus c. I don't have a y-axis. I've got a log y-axis. So the y is replaced with log 10 of y. I don't have an x-axis. It's log to the base 10 of x. So the straight line equation would be log to the base 10 of y equals m log to the base 10 of x plus c. So I need to show that it will be of this form. So start off with y equals kx to the n. I'm going to take log of both sides, because I know I'm heading towards something with logs in, so take log of both sides. And then I'm going to split this side up, so this will be log of k plus log of x to the n. Okay, so it's starting to look like what I'm trying to get towards here. I've got a log of x. And then rule 3, which says I can bring the power to the front. I'm going to write this bit first. I'm going to put the log k afterwards here just so it matches up with this format that I'm looking to head towards. So n log x plus log k. So this is in the form y equals mx plus c. This does match up with this here, where n is just the gradient and the y-intercept, which we know is 0.7, the y-intercept is equal to log to the base 10 of k. Remember the n and the k are coming from here. We're trying to get the link between x and y, trying to get the relationship between x and y. So part B, determine the values of k and n. So this is part A done. I've shown that it does satisfy the equation of a straight line, where I don't have a y and an x axis, I've got a log y and a log x axis. So that's that part done. So matching up here, the gradient is equal to the value of n here. So find the gradient of the line, y2 minus y1 over x2 minus x1. So the gradient's 2, so that means the value of n here is 2, so it'll be x squared. We need to find out the value of k now as well. So I know log of k, log to the base 10 of k is c. So I know c is 0.7 just from reading off there. So I know k will be 10 to the 0.7, just going from log format to exponential format. Evaluate that in a calculator, k is 5.01. So we could write at the bottom y is 5.01 x squared. Okay. So again, apply our log laws, rearrange, get it looking like the equation of a straight line. This will be the gradient, this will be the y-intercept. So find the actual gradient and the actual y-intercept from the graph that we've got to find our values of n and k. So here we had y equals kx to the power n, so we were raising x to the power n. On number 2, slightly different format. We've got y equals ab raised to the power x, so we're raising b to the power x, which is different to x to the power n. So if we notice, looking at the graph, we've done base e here, but we've got a log of y again. Here we don't have log x, we just have x. On the previous question, log x. The reason why it turns out like this is because of the format we've got here. Again, we're raising to the power x. So show this graph represents a relationship of the form y equals ab to the x. So we just need to show that this can be rewritten into a format that's the equation of a straight line. So again, take logs like we did before, split them up using rule 1. Bring the power to the front. So here I've got x log b. So that's x multiplied by whatever the log of b is. So I'd like to write log to the base e of b x, so it looks like mx plus c, but then it looks as though we're doing log of b times x, as in, if I wrote it like that, it would look as though I'm doing the log of bx, whereas what I want to really do is the log of b times x, so this would be my gradient. So just to avoid that even the possibility of that confusion, I'm just going to write x log b. Okay, so my gradient would be log b, and there's my x's, plus log of a. So c is just the log of a. So let's find out a and b. So I know my gradient is the log to the base e of b. So find the gradient using y2 minus 1 over x2 minus x1. Move from log format into exponential format. Should be negative there. So b will be e to the negative 0.4, so b will be 1.49. Log of a is c, so what's c? Looking at the diagram here, c is 3.9. Oh, just noticed that I didn't have that on the screen, guys, sorry about that. So going back to this one, log of b is negative 0.4, so b is e to the negative 0.4, which is 1.49, just evaluate that in the calculator. Here, log to the base e of a is 3.9, so a is e to the 3.9, which will be 49.40 to 2 decimal places. And again, if we want to write out the relationship between y and x, it will be 49.40, 1.49 to the x. Okay. As always, have we got the practice questions? So plenty of practice on page 21 and 22 of doing the first part and the second part, but it's quite important, guys, that you can just do this part, because you're getting 3 or 4 marks for that in any sort of assessment you'll ever do. Okay, it's a reasonably common question. It comes up once every 2 or 3 years. It's definitely worth being able to do. Okay. Good.